Now today, we will see how do we find equations whenever we know the roots or we know the solutions for that equation already. The main idea here is that we can find an equation when we know the roots or when we know its solutions. There's times where you know the solution and you want to know where those solutions come from, and for that we use this method. Okay, so let's introduce the method here. Now, the direction says let's write a polynomial p with the lowest possible degree that has the given solution. So here they give me the solutions. Whatever the equation is, we know that the solution is 3 and 2. So we want to know where those solutions come from. In order to know where the solutions come from, we're going to write those solutions in factor form. That is x minus the first solution, which is 3, times x minus the second solution, equal to 0. This is the setup. You're going to get each of those equations, each of those solutions, and write it in factor form. So the first solution is 3, so my first factor is x minus 3. My second solution is 2, so my second factor is x minus 2. Now that we have this, how do we find the solutions? Well, now we distribute. So let's distribute this. X times x, that's going to give me x squared. X times negative 2, that's going to give me negative 2x. Negative 3 times x, that's going to give me negative 3x. And negative 3 times negative 2, that is positive 6, equal to 0. This is the solution where this is the equation where those solutions come from. So let's simplify this. Can I combine any x squared? Nope, so bring it down. Here I see that I can combine those x's, so I obtain minus 5x. There's nothing to combine that 6 with, so bring it down. And there you have it. This is the solution. This is the equation where those solutions come from. So if you find the equation for x squared minus 5x plus 6 equal to 0, your solutions are going to be 3 and 2. Now, let's look at another example here. There's times where your solution can also be given in imaginary or complex numbers, but still, they follow the same idea. How do we do this? First, write each equation or each solution in factor form. So it's going to be x minus the first solution, which is 2i, times x minus the second solution. But notice that here your solution is negative, so we're going to have minus 3i. So we're going to have x minus 3i, which minus a minus, this is just a plus, so let's write it just as plus. So x plus 3i. We have this, we're okay. What do we do now? We distribute. So x times x squared. X times 3i, that's going to give me 3xi. The number, you multiply the numbers, so 1 times 3, that's 3. X times I is just xi. So we're done multiplying the x's. So now we need to distribute that negative 2i. So negative 2i times x, that's negative 2xi. And negative 2i times positive 3i, that's going to give me negative 6i squared. Okay, so we have this. What can we do? Let's see. Can I simplify my expression? Well, I see that can I combine any x squared? Nope, so bring it down. Here, I see that I have two xi's. So 3xi's minus 2xi's, that's equal to just 1xi minus 6i squared. Sorry, forgot to set it equal to 0 here. It should always be equal to 0 from the beginning, just like in our previous example. So now notice here, from our previous lesson of complex numbers, we have an I squared here, and we know that I squared is equal to negative 1. So now we have x squared plus xi minus 6 times negative 1, that's positive 6, equal to 0. So this is the equation where our solutions come from. Again, all we did, we just set it up using factor form, simplify, multiply, and then we will have our final solution. Now, is it always going to be with two solutions? No. No, you can be given 3, 4, or even 5 solutions, but the process remains the same. So let's find the equations. Let's find an equation where our solution is 1, 2, or 3. So the first thing I want to do is write it in factor form. So x minus my first solution, which is 1, x minus my second solution, which is 2, and x minus the third solution, which is 3, equal to 0. So now, what do you do if you have three roots? Well, first, I'm going to multiply this 2. I'm going to get a result, and that result, I'm going to multiply by the third. So let's do that. You should always try to multiply in pairs. So let's see. X times x, that's x squared. X times negative 2, so that's negative 2x. We're done distributing the x, so now we distribute the negative 1. So negative 1 times x, that's negative x. Negative 1 times negative 2, that's positive 2. So we have all this, and we still need to multiply it by x minus 3. Before we attempt the multiplication, try to see if you can simplify the first expression. I can simplify this as x squared. I can combine those x's, and we're going to have negative 3x plus 2, parenthesis, x minus 3. Okay, so now this is what we have. So we got to multiply this now. We do the same order. So x squared times x, that's going to give me x cubed. X squared times negative 3, that's going to give me negative 3x squared. Done distributing the x squared, so now I need to distribute the negative 3x. So negative 3x times x, so that's negative 3 x squared. Negative 3x times negative 3, so that's positive 9. Positive 9x. I'm done distributing the negative 3x, so what do we do now? We distribute that positive 2, so 2 times x, that's equal to just 2x. 2 times negative 3, that's equal to negative 6, equal to 0. In theory, this is your final answer. This is where your solutions come from, but let's try to simplify here. Let's see, is there another x cubed that I can combine it with? No, so bring that down, x cubed. I see that I can combine these x squares. So negative 3x squared minus negative 3x squared, that's going to give me negative 6 x squared. I see that I can combine these x's. So 9x plus 2x, that gives me 11x. Negative 6, nothing to combine it, bring it down, equal to 0. So this is the equation, such that if you try to solve this equation, your solutions are going to be 1, 2, and 3. So now, here's your entrance ticket. Find the polynomial given the following roots.